A cable of length 4 kilometers has a cross-sectional area of 2 times 10 power 6 meters squared and a conductivity of 8 times 10 power negative 6. Determine the resistance of the cable. So here you have, when you are given a calculation question, where you have to show some calculations, the very key thing here is don't start to work at it when you don't know the formula to apply, or you don't know whatever variables or quantities given the question relate. So in this case, let's list down whatever has been mentioned in the question. We have length, which is 4 kilometers. SI unit of length is meters, so this is the same as 4,000 meters. Another thing mentioned is the cross-sectional area, which is 2 times 10 power negative 6, that is in meters squared, which is SI unit. And the other one is conductivity. Conductivity, we can abbreviate it as G. Area A, length L. Conductivity is 8 times 10 power negative 6. That is in Siemens per meter. Conductivity is measured in Siemens. So we have these three, and we are taught to determine the resistance. So from the factors that affect resistance, we normally know that resistance is given by resistivity times length over area. So in this case, resistance is what we have been asked to calculate. Resistivity we don't know. Length we have. Area we have. Then how can we get the resistivity? There is this relationship, and I have seen this question having conductivity and the resistivity being very common. So what we don't have in this formula is the resistivity in order to get resistance. So what else can we use in order to get it? We have this relationship that resistivity is the reciprocal of conductance, which is 1 over G. And you know we have the conductivity. So reciprocal of this gives us resistivity. And also it is true that when you don't have conductivity and you want to get it and you have been given the resistivity, you take 1 over resistivity. Because from this formula, when you make conductivity the subject of the formula, you'll get 1 over rho, or 1 over resistivity, giving you the conductivity. So now we have the formula to get the resistivity. So we take 1 divided by conductivity, which is now the same as the reciprocal. So this one, when you compute it in the calculator, it is good to know how to write it. It is good to put 1, you divide by, then you put this in brackets like that in order to get the correct answer. So when you do this, you'll get 125,000. This is resistivity. So resistivity is measured in ohm meters. So we got the resistivity and we have the formula. We can apply now to get resistance. So our resistance will be equal to our resistivity. We multiply by length, and remember to work with SI units, divide by area, which is 2 times 10 power negative 6. So you can multiply this 125,000 times 4,000, then the answer you divide by 2 times 10 power negative 6, and you have to put them in brackets. So you have to apply in the calculator this way. You put this in brackets, you multiply by 4,000. This one you divide by 2 times 10 power negative 6, because sometimes when you put it without the brackets you can mess it. So when you do that, this will give you 2.5 times 10 power 14, and this is in ohms. As you can see, this value is very big, and this one is because resistance is normally directly proportional to length. So as you can see, 4-kilometer length of cable should have a high resistance, and that is why we are getting a very huge value for that. So that is how that question is worked out.